Write an equation for the nth term of the arithmetic sequence 5, 7, 9, 11, and it goes on and on and on and on. All right, so what we're doing on this, when it says write an equation for the nth term of the arithmetic sequence, we're looking for a formula, all right, a formula in terms of n. It's almost like a y equals mx plus b moment for those of you who've done slope and intercept. So we're looking for a pattern, and we're looking for how to get that in terms of n. N, by the way, is the number of the term. So, for example, 5 is the first term. That would be n equals 1. 7 is the second term. That would be n equals 2. You get the idea. 9 the third term, so n would equal 3. Well, we're looking for a formula that will give us those numbers. Now, notice it's arithmetic because there's a common difference between those. So we've got a nice little formula to work with here, all right? And first of all, it's going to be our a sub n. Let me switch off here. Got the wrong pen there. Sorry about that, guys. Here we go. We're going to pick up a sub n, and that will equal our first a. All right, that's what that a sub 1 means. And we're going to add an n minus 1 factoring because we're going to need to reduce it by 1, and times that common difference, d. That's a formula, and like I've told you before, all these variables don't make much sense until we can put some numbers in there, all right? So let's go back and let's place some things into this formula, all right? First of all, I'm not worried about what a sub n equals to. That leaves it open for me, okay? So I've got a sub n, but what I do know is 5 is going to go in this first slot, all right? There we go, all right, put that 5 in there. And n minus 1, I don't know what n is, so we're going to keep it. I do, however, know that the difference is 2. It's 2. So there's our setup. So now it's just simplification. We're going to leave the left side alone. It's just going to be like a y or a variable, but a sub n simply means the nth term, all right? On the other side here, we can keep 5, but let's distribute that 2. So many times we think the 2 being in the front makes it distributed, but we're going to distribute it backwards. How's that? So we're going to put 2n minus your 2, and there we have it, a sub n. And I'm looking at this point of a sub n equaling, it looks like 2n plus 3, because these two just come together, 5 minus 2, and there we have it. Again, this allows me to put any value of n, and that will give the term. So let's check it back through and see if it works. Remember I said our first term is 5, so I put 2 times 1 plus 3. Bang, we get 5, all right? Put a 2 in there for the second term. 2 times 2 is 4, add 3. Hey, we're at 7. And you keep looking along here. How about it? Put in the third term. 2 times 3, 6, add 3, get 9. So you see what's going on there? The pattern works. You say, Ernie, when does it end? Well, it doesn't. This is an infinite sequence, all right? It works anytime. If I want to find out what the 50th term is, I just simply put 50 or 50. How about that? 2 times 50 gives us 100. Add 3, be 103. So again, that's the idea of how we work this. So what's the formula? Right there it is, 2n plus 3. And that means 2 times n plus 3. And I want to put one other difference thing here. Notice that this, it's like saying y equals 2x plus 3. You could graph this thing. Oh, it'd be very easy. You wouldn't be able to write all the terms, or you wouldn't make a straight line, or they're going to line up. But you're looking at the points there, and you could graph those points and say, wow, those look pretty linear, and they would be. They would be. A discrete function, by the way, all right?
For more math help, visit TNLearn.org.